Okay, good afternoon, everyone. We are from Huazhong University of Science and Technology. I'm glad to introduce our work for you here. Then, the title of our work is The Energy-Saving Clothes Dryers with Heat Recovery Based on Peltier Effect. Then, I will introduce for you from several aspects. Okay, you can see these two pictures is our design inspiration. The first one is hanging clothes out. The second one is the city like we live Wuhan. The air is humid, so the clothes is uneasy to be dry. So a clothes dry should be there. Okay, it's about the market status. This one is electric heating dryers. Its principles and structures are brief, but high energy consumption, hot and humid gas discharge directly is his drawbacks. Then, casing condition dryers. It's a kind of low energy production, but complicated structure, high cost and expensive is its drawbacks. About the working principle, you can see. At first, it's about the Peltier effect. Peltier effect is be found by Jean Peltier in 1934. Jean Peltier is a watchmaker and he is an unprofessional physician. He found the Jean Peltier effect. Now you can see, if electrified, this is a TEC, which is made by the Peltier effect. It can transfer the cold quantity Q2 and electric quantity Q1 to the hot end. Then the quantity of heat Q3 is equal to Q1 plus Q2. Its heating efficiency can reach 1.6. This video is about the structural analysis. This is fun. This is the most important part of the work, the TEC. Now it is insists of the power supply, the TEC module, and the regenerative cycle module, and the enclosure module. But how it works? You can see this. At first, some fresh air coming, then air heating, then some moisture absorption, and recurring condensation and ray of water. At the same time, the preheating the cold air, this is a cycled operation. Meanwhile, we set assisted saturation, means part of the hot air circulation. Okay, it's about innovation. At first, energy saving. 1. Make full use of the hot end. Thermoelectric materials. Heating efficiency can reach 1.6. Electric heater. Heating efficiency is less than 1. 2. Utilize the cold end. The cold end lower than the dew point temperature. Condensation, dehydration. Efficient drying. 3. Reuse the waste heat. Use closed cycle, add regeneration cycle and oxygen cycle, reuse the heat. Then we make energy use to alchemy, and our work is super energy saving. Then about the emission reduction. 1. No refrigerant. Thermoelectric refrigeration won't destroy the ozone layer. 2. Little hot and humid air emissions. Closed loop, the cold and condensate. 3. No working noise, long service life. Thermoelectric materials have no moving parts, long working life. so we can realize zero emissions nearly. We also did some tests about our work, including experiment, simulation, numeric calculation, and so on. This is what we did. Also, you can see the prototype parameters in this. Then you can see from these two pictures, we can see the large market demand. Then we can see from this, the efficiency is very good. Okay, we can see this is what we did the work cost. Our cost is 870 RMB, but as a condensing dryer, it will cost 7,000 RMB. If it's function replaced by our work and washing machine, the total cost will only 2,500. It's easy to compare. For the TEC has some drawbacks that we can't resolve well now. So our target market is like wine shop, hotel, hospital, and home, where the capacity is small. So that's all what I want to say. Thanks for your attention.
I come from home appliance division. We have discussed your idea. Just one question.
Yeah.
The semiconductor component is very expensive. Why you can do it to meet cost requirement?
The most cost is mainly about the thermoelectric chip, and the cost is only about 300 yuan if all the structures and the project is made by ourselves, and the total cost is accurately calculated by us, so that 870 RMB is very reliable.
Semiconductor component.
Yeah.
Price much higher than heater.
But what we focus on is the semiconductors energy saving and emission reduction. Because if you use some the regular PTC clothes dryer, it will cause some heat waste. But the semiconductor using our product, we can use both of its hot end and cold end, and it will not cause some emissions.
I'm still wondering how it works in practice. Does the cloth needs to be spread out in order for the full effect of evaporating and condensing to take place? Can it work if the cloth itself is all crumpled in one bundle?
To be frank, we haven't think about that. It's just a prototype, and there are some you can see. There's a structure you can hang the clothing in there, but the size of the chamber is much smaller, so you cannot use it in mass production. It just fits some small capacity use. And these clothes dryers is mostly focused on the quick dryer. Yeah, thank you.
Okay, thank you.
谢谢。
And you can see this box is our prototype of the clothes dryer, and our main part of this machine is this.
Focus on the question that we asked.
Yeah.
What's the cost? Because you seem to use the semiconductor materials, right?
Yeah.
And you need a large area, I believe. Then the cost will be.
Yeah. This is the semiconductor in the 2 ground panel. Yeah, we have calculated because we bought every material ourselves. The semiconductor chips is about 12 RMB per chip, and we use 10 chip in this section. So the cost is not very high in comparison to the other PTC clothes dryer. Yeah, the cost is
12.5.
12 RMB per chip. Yeah,
So
and we use
10.
yeah, and we use 10 chips in.
And what's the power?
And the power is you can see those charts. You can see those charts.
Yeah.
This is our clothes dryer, and this is the traditional clothes dryer, and the power is 500 in comparison to 2000. And our capacity is about 2 kilograms wet clothes. This is much lighter than the traditional one, but what we focus on is quick dry and in small capacity place like hotels and in our homes.
Okay, you need to be careful in comparison basis. This
Here. We have calculated that we use this clothes dryer plus a traditional washing machine. The cost will be about 2,500 RMB.
Okay, because when you put the clothes, you need to use the hammer.
Yeah.
Put it 1 by 1. Okay, but in the washing machine, there are mixed cases. These are 2 different.
There's 2 different types of
yeah.
clothes dryer. Yeah, but this is just the prototype, and the capacity is quite smaller. And what we focus on is not the heat efficiency. It's that we can use both the hot end and the cold end of the thermoelectric. Yeah, you can see this channel, these runners, the hot air, while it absorbs the moisture of the wet clothes. The hot humid air will come to the cold end, and after our calculation, the cold end's temperature and the hot end's temperature can reach about 30 centigrade.
You mean the difference?
Yeah, the difference can reach 30 centigrade, so that the hot humid air can reach its dew point. The water can be condensed out of the system in liquid forms.
But you have to have these moving parts, the fans, to make this forced airflow.
Yeah.
Right? So
Yeah.
this probably will shorten the lifetime of your product.
Yeah.
You stress that you don't have a moving parts, but these are moving parts.
This because these materials are bought and not made.
But you don't have any alternative without fans to make this.
We mean no moving parts. It's like the roll barrel, like the traditional clothes dryer. We just use this fan as a moving part. So the working life may be prolonged.
I suggest that you use the cold air as an air conditioner. Okay, and then the byproduct is the hot air for drying the clothes.
Yeah,
That makes more sense.
Yeah,
than
this
the
is
other way.
what we are about to further. Yeah.
Thank you.
Thank you.